we finally have enough information to solve the following polynomial. Again, this was given by x raised to the n plus c is equal to 0. And the way that we're going to go about doing this is by using de Moivre's theorem. And what this says is that if we raise a complex number to a power, then it's going to be of the following form in polar form. And the way that we're going to go about solving this is, again, we need to go ahead and subtract c from both sides to give x raised to the n is equal to c. And so therefore we want all nth roots of c. So we want to find out what numbers are c raised to the 1 divided by n. And this is where we apply this theorem here. So a corollary to de Moivre's theorem is how to find the nth root of a complex number. And this is going to be given by the following. If we have a complex number in polar form and n is a positive number, then the complex number z has n distinct roots, which are given by the following. For k values where k is between 0, 1, 2, all the way up to n minus 1. Before we look at an example of solving a polynomial like this, let's go ahead and find the cube roots of a complex number. This is example number 8. And we're trying to find the cube roots of the following. And the first thing that we have to do is we have to place this number in polar form. So we need to find what the modulus is, and then we also need to find what our argument is. So here's the point in the complex plane, 1 plus I, again forming our right triangle with base 1 and height 1. The modulus then is given by the square root of 2. This angle theta here, which is the acute angle of our right triangle, is going to be given by pi divided by 4. So therefore, by the previous corollary, we're going to have 3 cube roots. And so applying our corollary, we'll get that the cubed root of 1 plus I will be one of the following. Either it's the square root of 2 raised to the third times cosine of pi divided by 4 plus I sine of pi divided by 4, or it's the square root of 2 raised to the third times the cosine of pi divided by 4 plus 2 pi divided by 3. Oh, so I forgot 3's down here. Now let's continue with what we were just working on. So this is I sine of pi divided by 4 plus 2 pi divided by 3. And the last possible cube root is given by the following. Again, we'll have cosine of pi divided by 4 plus 4 pi divided by 3 plus I sine of pi divided by 4 plus 4 pi divided by 3. So I won't write out completely what the final answer is. Well, the final answer is going to be what happens when we simplify the argument of these 4 numbers here. And let me just go ahead and give you the solution on the next page. So finally, let's look at one more problem. This is going to be example number 9. And we want to go ahead and solve the following polynomial, z raised to the 4th plus 1 is equal to 0. So again, we have z raised to the 4th is going to be equal to a negative 1. And this tells us that we want to find all z values where we have negative 1 raised to the 4th. So we want to find the 4th roots of negative 1. So again, we need to go ahead and just identify some information about the complex number negative 1, such as that the modulus is going to be equal to 1, and our angle theta is going to be equal to 3 pi, just pi. Okay. And so applying our formula, we're going to have 4 roots exactly. And so either we'll have 1 raised to the 4th times cosine of pi plus I sine of pi, or we'll have 1 raised to the 4th of cosine of pi. Oh, I did it again. There should be a 4 here, since this is the 4th root. The next one will have cosine of pi plus 2 pi divided by 4 plus I sine of pi plus 2 pi divided by 4. The next one is 1 raised to the 4th of, again, cosine of pi plus 4 pi divided by 4 plus I sine of pi plus 4 pi divided by 4. And finally, 1 raised to the fourth of cosine of pi plus 6 pi divided by 4 plus I sine of pi plus 6 pi divided by 4. And the last step that we just need to do is we're going to go ahead and simplify each of these. So let me go ahead and copy these to a new page. And this doesn't simplify anymore. This is just going to be equal to cosine of pi divided by 4 plus I sine of pi divided by 4. This is going to be equal to cosine of 3 pi divided by 4 plus I sine of 3 pi divided by 4. This term we're going to get cosine of 5 pi divided by 4 plus I sine of 5 pi divided by 4. And finally at this term here we'll get cosine of 7 pi divided by 4 plus I sine of 7 pi divided by 4. And these are going to be our complex roots, or sorry, the fourth roots of our complex number, -1.